All right. Professor Avi Loeb, thanks so much for taking the time to connect today.
It's a great pleasure.
So, for those who don't know, Avi Loeb is the head of the Galileo Project. He's the founding director of Harvard University's Black Hole Initiative. He's the director of the Institute for Theory and Computation at the Harvard Smithsonian Center for Astrophysics, and was a former chair of the astronomy department at Harvard University. And he wrote a new book called Interstellar. Avi, what did I miss there? Any accolades that I missed?
Well, you could have saved time if you just referred to me as a curious farm boy. I was
Okay.
born on a farm and very much
Oh,
connected to nature, and not so much to how many likes I get on social media.
what farm were you born on?
Yeah, we had the uh, pecan nuts, we had the oranges, grapefruits, we had the chicken, and I used to collect eggs every afternoon. On weekends, I would drive to the hills of the village and read philosophy books. That was my passion at the time, um, and I really connected to nature much more than to people, and it still shows in the way I do my science. I'm really curious. Actually, right now I live not very far from the Walden Pond, where Henry Thoreau went and sort of tried to distance himself from the Industrial Revolution. He argued that we should get closer to nature, which is pretty much what I enjoy doing. And for me, nature is actually the universe at large. And anytime I would take a one-way ticket away from Earth to visit distant places in the universe.
So let's talk about then how did you go from a farm boy to a physicist and a research scientist? And specifically, my question is what first got you interested in the search for extraterrestrial intelligence?
Right. So it was all a combination of circumstances because I grew up in Israel and um, serving in the military is obligatory. And since I loved philosophy, it addresses the fundamental questions about our existence. The closest thing that I could get was to pursue physics within the military because there was a program that allowed me to finish a PhD in physics and mathematics at age 24. And at the time, I led a project that was the first international project to be funded by the Star Wars Initiative, the Strategic Defense Initiative of President Reagan back in the mid 1980s. And that actually provided a few $1 million a year in funding and brought me to visit Washington, D.C. And in one of the visits, I was advised to visit Princeton. And I went to the Institute for Advanced Study, where Einstein was a professor a few decades earlier. And the administrator there said there is only one person who has free time, and that's Freeman Dyson, whom I heard about during my studies and admired. And when I met with Freeman, he introduced me to John Bacall, who was the astrophysicist there. And John offered me, after inviting me to visit for a month, he offered me a 5-year fellowship under the condition that I'll switch to astrophysics. And then there was a position, a junior faculty position offered at Harvard University, and I applied to it. They offered it to someone else first, and that person declined because the chance of getting tenure at Harvard is really small. And I ended up getting that offer. And once again, for the second time, it was an offer I could not refuse. It's sort of like in The Godfather. I mean, I always had plan B of going back to the farm and working there. So I wasn't worried about getting tenured. But within 3 years, in December 1996, I received tenure at Harvard because Cornell University offered me tenure at the time. And so I ended up an astrophysicist. I ended up also leading the astronomy department at Harvard for 9 years, starting in 2011. So I realized that even though it's an arranged marriage, I'm actually married to my true love because there are fundamental philosophical questions that we can address within the realm of astrophysics. And then in 2017, there was this first reported interstellar object that was discovered. It was given the name Oumuamua, the size of a football field, that looked really weird. And I actually wrote a paper a decade earlier saying that the telescope, the survey telescope that was used, will never find any object from outside the solar system because there shouldn't be enough of them. We calculated based on what we know about the solar system that there aren't enough rocks the size of a football field for one of them to show up during the survey. And the fact that my forecast was, not confirmed, allowed me to learn something new. For me, it's an opportunity. I mean, especially when there is an anomaly, it's actually an opportunity to learn something new. So it means that there are many more objects than we expected. And then this object showed really unusual properties, and it didn't look like a rock. It was, it had an extreme shape based on the fact that every 8 hours it tumbled, and the amount of sunlight reflected from it changed by a factor of 10. And moreover, it was pushed away from the sun by some mysterious force. And so altogether, this suggested to me that it may be artificial in origin. Maybe it's a very thin object that is pushed by reflecting sunlight because there wasn't any evaporation from it, no dust or gas, the way you expect from comets. And something else must have pushed it. And nature doesn't make very thin objects like that. So this brought me to the recognition that we might want to search for interstellar objects, objects that came from outside the solar system, like this one, which might be artificial in origin, because we ourselves, in 2018, the test launch of the Falcon Heavy had a dummy payload of the Tesla Roadster car of Elon Musk, and it's now on an elliptic orbit around the sun. And in 20 million years, it could collide with Earth and would appear as an unusual meteor. So we should be ready.
What would happen?
Yeah.
What would happen if it collided with Earth?
Oh, it will appear as a meteor. It will burn up in the Earth's atmosphere. But if astronomers were to notice it unexpectedly, they would argue it's a rock of a type that they've never seen before. And my point is, there could be space trash out there. That realization brought me into the research that I'm doing right now, actually actively searching for interstellar objects of artificial origin from another civilization, because it will change everything. If we realize that we have a neighbor, we could learn from that neighbor, and it would inspire us also to go to space. And
yeah, definitely.
So altogether, this is the reason I'm doing it right now.
Wow. And to talk about your research more, so you've been at the forefront of cosmological research for decades, and that includes pioneering work on the Lyman alpha halos around early galaxies. So could you talk about the significance of those halos, and specifically how that contributes to our understanding of the universe's evolution?
Yeah, so I started my career in astrophysics. I had to invent myself because I haven't had any record. In fact, I didn't even know how the sun shines, which was really embarrassing, coming to work with John Bacall, who focused on the sun in his throughout his career. At any event, I decided to work on the first stars and galaxies, which is the scientific version of the story of Genesis. Let there be light. And back then, there weren't many people interested. And I sort of pioneered some of the research aspects of this, and now it's very popular with the Webb telescope, seeing the first galaxies. So as part of my study, I asked the following question. The universe, after 400,000 years, was cold enough as a result of the expansion for hydrogen atoms to fill it up. Free electrons and protons combined to make hydrogen atoms. And that was, 400,000 years after the Big Bang, relatively early. And then the first stars formed 100 million years later. They started breaking up the hydrogen atoms because they produced ultraviolet light that can break hydrogen into a free electron and a proton. And so what ended up happening is that the hydrogen became just like Swiss cheese. There were these holes surrounding galaxies that started growing. And once there were enough stars around to produce one ultraviolet photon per hydrogen atom. The hydrogen atoms were destroyed throughout the universe in the diffuse medium between galaxies. And this process is called reionization. But before it started, there were all these hydrogen atoms surrounding galaxies, and they behaved like dense fog because if those galaxies were emitting radiation at a wavelength that can resonate with the hydrogen atoms, and the most effective such transition is called Lyman alpha. It's named after Theodore Lyman, that was the chair of the physics department at Harvard about a century ago. And he discovered that hydrogen has a transition between the ground state and the first excited level, and that's called the Lyman alpha transition. Alpha for the first transition. There are other transitions that can go from the ground state to even higher levels. But often we see this transition as a spectral line in galaxies nearby, because the hydrogen in those galaxies gets excited and then it emits the Lyman alpha line. However, if a galaxy is embedded in a dense hydrogen gas in the early universe, those hydrogen atoms along the line of sight to the galaxy scatter the radiation. They absorb the Lyman alpha photons and they re-emit them. And as a result, it's just like looking at a lamppost that is embedded in fog. You see just a halo of radiation scattered around the lamppost. And the same is true for those early galaxies. We should see a halo. And we calculated how the properties of this halo, how should it look like and whether it's detectable, with a colleague of mine, George Rybicki. And these are called the Loeb-Rybicki halos after our paper. And so we predicted that. And back then, even though I was a member of the scientific advisory board for the James Webb Telescope, what is now called the James Webb Space Telescope. Back then, it was called the Next Generation Space Telescope. I became involved in it in 1995. And the paper was written in 1999, just a few years later. And so we did not really know what the telescope capabilities would be. We were a bit optimistic. So just over the past few days, we finished the paper with a colleague of mine, Hamza Padmanabhan. She's a researcher from Switzerland. And it turns out she is actually the daughter of a physicist that wrote the first book that I read as I decided to work on cosmology, the study of the universe. And she told me that she read my book about the first galaxies in the universe, and it's sort of like the art of paying it forward. Her father educated me on cosmology, and I educated her. She was inspired by my book to study the first galaxies. It's really interesting. And so we wrote a paper together about whether the Webb telescope can detect these Loeb-Rybicki halos around the first generation of galaxies. And the answer is yes, because the Webb telescope is seeing galaxies that are far brighter than expected. And that makes the halos even more luminous than we expected some 25 years ago. And so altogether, even though the telescope is less capable than we anticipated back then, the galaxies that exist early on in the universe, less than 500 million years after the Big Bang, 500 million years or so after the Big Bang, those galaxies, some of them are extremely bright, and we should be able to see the halos. So I'm really excited about it, because the next step would obviously be to look at the data coming from the Webb telescope and find out if we do see these halos. And I should say that would be a new way of mapping the fog of hydrogen filling up the universe at those early times. So it really will be the first time that we observe directly the hydrogen less than 1 billion years after the Big Bang.
And this work and a lot of other work that you've done really challenges the idea of humans being at the center of the intellectual universe. So how do you see humanity fitting into the grand scheme of things in the cosmos?
Yeah, so first, an interesting anecdote. The human body is, in terms of its mass, is at the geometric mean between the mass of a proton and the mass of the sun. What I mean by a geometric mean is that you take the square root of the product of the two things. So you take the mass of the proton and the mass of the sun, and if you put it on a logarithmic scale, the mass of our body is exactly in the middle, which is an interesting coincidence. And the other coincidence is that the mass of the sun and the mass of the observable universe, if you take the geometric mean of these two, you end up with the mass of the Milky Way galaxy. And that's interesting because it shows you that humans are really small objects relative to what you find in the universe. That they're at the geometric mean between the sun and the Milky Way, whereas the Milky Way is at the geometric mean between the sun and the mass of the observable universe. Quite interesting. And that leads me to wonder, suppose we are also at the geometric mean between the intelligence of a single cell organism and the most intelligent life form that exists in the universe. Just imagine how much more intelligent that life form is. We tend to think that we are unique and special and that there is nothing like us. But to me, the fact that we arrived to the cosmic stage relatively late, just a few million years ago, the human species, which is one part in 1,000 or so of the age of the Earth, and also we are not at the center of the universe. That's what Nicolaus Copernicus told us. And I actually went to his birthplace just a few months ago because the Polish government celebrated the 550 years to his birth, and they invited me to give a keynote lecture on that. And I gave the talk about the next Copernican revolution that will basically be about us not being at the intellectual center of the universe. That's the next one. So I just wanted to point out that we need to allow for a higher intelligence out there, and that could have huge implications for humanity if we find it. And it's all about seeking evidence, because a lot of people have very strong opinions, and that includes Elon Musk, who says, "I've never seen any aliens around us." Of course, you will not see it unless you search for it. And Enrico Fermi 70 years ago said, "Where is everybody?" Well, that's what every single person asks. But the truth is, to find a partner, you really need to go to dating sites, or you need to look through your window or leave your home. And Enrico Fermi didn't search for the evidence. And that's what science is all about. And when people say extraordinary claims require extraordinary evidence, I should add to that extraordinary evidence require extraordinary funding, and it requires a lot of effort. Without $10 billion, we would not find the Higgs boson. We had to invest that in the Large Hadron Collider, and the same was about the Webb telescope. It cost $10 billion to find the first galaxies.
Let me ask I have two questions I'm hoping to get to. So you mentioned Elon Musk, and you said that Elon Musk says he hasn't seen evidence of extraterrestrial life. And I think what you just said is that you have to look for it. So here's my question, because I don't know his position very well, but my understanding of Elon Musk's position is that he's not saying there's no evidence at all. He's saying that he's surveyed the evidence from, let's say, yourself, and others, and he's saying, "Hey, I've looked at the available evidence, and I'm not convinced." Am I accurate? Is that his viewpoint?
No, I think what he's saying is basically that he has a fleet of thousands of communication satellites, but there is no evidence from the data that he has access to for any objects that are maneuvering around the Earth that would indicate an extraterrestrial origin. That's the latest he said.
But he also has access to the internet. So, like, your research aside, I guess my one and only point there is that I assume what Elon Musk meant was that, given that he has access to the internet and to the knowledge of our society, that when he says that he has no evidence, he's not referring strictly to the SpaceX Starlink evidence. He's talking about, like, collectively evidence. And I guess
but let's apply the same approach to the Higgs boson. Before 2011, when it was discovered by the Large Hadron Collider.
And by the way,
So,
don't let me don't let me mischaracterize Elon Musk or
no,
yourself.
but I'm
Might have
saying,
been-
so suppose you were to surf the internet before 2011, or look around yourself, you would not see any evidence for the Higgs boson. Okay, so to find the Higgs boson, you need to invest $10 billion in the Large Hadron Collider. It's a project that took decades. And so the whole point is that new knowledge does not fall into our lap. If you don't do the work, you can't expect to gain new knowledge. And the work that I'm talking about is actually checking for interstellar objects. And only over the past decade, we started finding them, okay? And so what I'm doing in particular is, for example, we have a meteor that was spotted by US government satellites in 2014, and a decade ago. And I want to see what it was made of, to find pieces of it and examine whether it was a rock or a gadget, an artificial, a technological object. This is called science, where you don't surf the internet to find the answer. The answer is not coming from X or Twitter. It comes from looking for the evidence. And that's the work of science that was done by the Large Hadron Collider, that was done by the Webb telescope when it found the first galaxies. So, science is not about us, having a drink and checking whether there is anything around us, because you will never find the Higgs boson that way.
Got it. And I back to your analogy, Professor Loeb, about so the idea is that the mass of a human is at the middle between the mass of a proton and the mass of the sun on a logarithmic scale. And
Right.
so, and then not only is that a coincidence, but it's also a coincidence that the mass of the solar system, the Milky Way, relative to the mass of the universe, has a similar relationship.
Yeah, exactly.
And
so the Milky Way is,
and so based on that coincidence
Mhm.
or that analysis, you suggested that perhaps in the same way that there are things much more physically massive than humans, that perhaps there are things that are so much more intelligent than humans. And my question is, why are we allowed to make that analogy? Like
Yeah.
what about the relation that you've seen or observed between physical masses suggests that there can be any correlation? Like why is it appropriate for us to make that
Right.
assume that mass
Mhm.
would somehow connect to intelligence?
Right. The reason I bring this up is because intelligence, as far as I'm concerned, is about processing information. And the more, the larger is the ability to process information, the more intelligent the system could be. And we see that with computers in terms of the number of chips and the ability of each chip to process information. Now, of course, you can miniaturize the size of chips, and that's what the commercial
But
sector is doing.
elephants aren't smarter than us.
No, because the mass is not sufficient. You need the system to be complex, and you're right that the mass is no guarantee. You can have a very massive object that has no intelligence whatsoever, but the ability to use more resources in terms of physical mass in principle allows you to have more connections. And so, for example, AI systems right now, artificial intelligence systems, are getting close to the number of synapses in the human brain in terms of the number of connections they have. And indeed, with GPT-5 and beyond, we might get to the point where those AI systems, the large language model systems, would impress us on some tasks as being more intelligent than humans. And they may have gotten there already, because some experts argue that they hallucinate, they are not as good as humans. But I worked with many summer interns, and many of them hallucinate. And if you look at the humans, there is a large spectrum of intelligence. So we might already be there, where the AI systems we produce are already getting to the level of humans. And what I'm saying is that this is an exponential process, the ability of AI to grow in its abilities, simply because you will be able to use more and more chips as time goes on, and the number of connections will go up. And then eventually, it will be a system that we cannot comprehend, because it's far beyond us. And if I were to extrapolate that to the more distant future and imagine those AI systems, improve themselves without our help, because they would gain in experience and they would perhaps even design new AI systems that are better than them. And so if that happens, there is no limit, and the only limit would be physical in terms of the number of chips that they can have. And that's why I'm saying that, in principle, they can have much more mass than they currently have, and that would be limited by how much silicon can be used and manufactured to make chips. And just having a more massive object could help in that regard. But uh, I think it gives us a sense of modesty, because as of now, until now, we were the most intelligent species on Earth. And that led us to hubris. In the old days, there was religion. And religion argued that there might be a God, a superhuman entity. Moses saw a sign for it in the burning bush that was never consumed, and that led him to believe in God. And then in 1882, Friedrich Nietzsche, the philosopher, said, God is dead. Okay. And that led to the hubris that we have in the modern era of science and technology, where, people, Enrico Fermi asks, where is everybody? Because we as humans feel lonely suddenly. And the point is that there might be a replacement for that in the future. If we construct an AI system far superior to us, or if we meet extraterrestrials that are far superior to us, that would serve a role similar to God, because it will bring back a sense of modesty that characterized Moses, that there is a superhuman entity that is far better than us. And I think it's really needed, because it will, first of all, it will be very different than religion. It will be something that we interact with, either AI or extraterrestrials, and it will substitute for the notion of God.
Do you believe in God?
I believe in extraterrestrials. So I believe they exist. I believe that it's very unlikely that we are alone, that we are the smartest that ever.
Do you believe in God, though?
Yeah, well, that's my sense of God. So the way I define it,
Extraterrestrial is God?
it's a substitute, because already we are almost at the point where we can produce life in the laboratory. And moreover, in the future, if we understand, if another civilization understands how to combine quantum mechanics and gravity, they might have quantum gravity engineers that could create a baby universe in the laboratory. So then I ask you, okay, suppose there is an entity, superhuman entity, that is far more intelligent than us, that can create a baby universe in its laboratory, and that can create life in its laboratory. Isn't that what you might call God? And it would be able to create miracles as far as you are concerned, because it would employ technologies that we don't have access to. So for you, it would look like a burning bush that is never consumed, the way Moses was stunned. He was filled with religious awe. You might also be filled with religious awe once you encounter them.
Did that God 2,000, 5,000 years ago contribute to the writing of the religious texts?
We don't know what that it may have been the imagination of people, because there were phenomena in nature that they could not understand. And when you are a kid, there are lots of things you don't understand, but you have your parents that guide you and protect you. When you become an adult and things happen to you that you don't understand, you look for sort of a parent-like figure. And that is that's the role that the religion plays, that it gives you a sense of, even though you don't have your parents taking care of you and explaining everything that happens to you that you don't understand, you have this other parent-like entity that you might call God, that protects you if you do the right things and takes care of you. And that's a good psychological thing to have. It gives you a sense of safety, security. But what I'm saying is, I don't know if that was the imagination of people in previous generations, or they encountered something unusual, like an extraterrestrial entity. At any event, we don't need to talk about that. We can do the search ourselves and see what our neighbors are like.
So let's talk about that. You're saying we can do the search ourselves and see what our neighbors are like. But on the other hand, your insights into the limitations of chemical propulsion for interstellar travel offer a sobering perspective on our current technological capabilities.
Right. Yeah.
So
So
given that, what breakthroughs do you think are necessary to
right.
overcome these limitations and enable long-term exploration of the cosmos?
Right. So rockets that we already have can travel at about one part in 10,000 of the speed of light. Okay. And the size of the Milky Way galaxy, from one side of the disk of the Milky Way galaxy to the other side, we're talking about several tens of thousands of light years. Okay. So if you multiply that by 10,000, it would take less than a billion years to cross the Milky Way galaxy with existing chemical rockets. Okay, which is, a short time. It's less than a tenth of the age of the universe, and you can imagine trips that took place because most of the stars formed billions of years before the sun. So there was plenty of time for even chemical rockets to reach our backyard. But it's a challenging journey because humans, obviously cannot survive for so long, and it's really difficult to imagine a lot of generations embarking on a trip that takes a billion years or even a million years. Instead, what I think the solution is to have AI systems because they can be autonomous. And on this, there is a cautionary remark because we haven't used AI in space as of yet. I see that as the frontier, the future, because as of now, we are helicopter parenting all the probes that we send to Mars. Actually, NASA had a helicopter sent to Mars that was managed by engineers in the Jet Propulsion Lab in Pasadena. And I call that helicopter parenting because we were giving orders to the robot as to what to do. But a much more effective method of exploring distant destinations is letting the system explore, be autonomous, and explore the environment on its own and make decisions on its own. It's sort of like sending your kids out of your home. You don't ask I at least don't ask my daughters to report back to me about every step of their way. Every now and then they call us and say what happened over the past week or so. And, that's the way we should treat space exploration. We send those autonomous systems that have AI and they make their decisions on a short time basis. And the reason is that, it takes time for our signals to reach them. So that would cause a huge delay in their ability to function. And moreover, it requires a huge amount of information to be exchanged between them and us. And if, on the other hand, if they are autonomous, they don't need to do that. They will just report back on anything unusual that we would like to know about. And I think that's the way to explore interstellar space. And it will not be with humans. And I have no issue with AI systems representing us, the way I have no issue with my daughters representing our family far away. I sort of created them with my wife, my daughters, and I'm proud of whatever they do, even if I don't fully understand it. A lot of people are worried about the future with AI, and the only thing that comes to my mind is that those people are not very good parents, because parenting is all about managing intelligent systems that you can't control. You cannot really control your kids. And why aren't we worried about our kids? Because we give them good education and then we hope that they will do the best based on the guiding principles that we provided them. So the same thing with AI. We will train AI systems based on our guiding principles, and then let them go on their own into space and explore. And they have the patience to survive millions or billions of years in space. We will provide them with the hardware that allows them to survive. And so I see that as the future.
And with regards to this future that you're envisioning, you've also spoken about the concept of interstellar gardeners. And this is the idea of a cosmic stewardship, let's call it, and responsibility. So let's talk about this cosmic stewardship and what steps can we take to embrace this role and to ensure flourishing across the
Right.
cosmos.
So there is an interesting question. Why did we came about? I mean, obviously, the popular idea is that there was a soup of chemicals, 4 billion years ago, once the Earth cooled, that started to produce microbes that then became complex life forms, and the process ended up in chimpanzees that we came from. Okay, and of course there is another possibility that someone intervened, that we have intelligence, and it's not at all clear how that came about. And so that I call an interstellar gardener. If there was someone from outside that seeded intelligent life on Earth because it emerged near another star. And when you deal with hundreds of billions of stars in the Milky Way galaxy, there is a better chance that intelligence will come along. And then what you can imagine is that once it comes along, and that civilization is successful in sending or launching seeding spacecrafts, they would just seed the galaxy with intelligence. I mean, they could have self-replicating probes, just the way think about the dandelion flower. Dandelion seeds are carried by the wind, and they reach great distances and carry the DNA of the flower, and you get more dandelion seeds far away. And so in the same way, you can imagine technological dandelion seeds, and just self-replicating probes that go places and reproduce what they were designed to make. They reproduce the DNA, that the information that they carry. And just like in biology, but except now we are talking about technology. So technology can reproduce, and that's an idea that John von Neumann thought about, self-replicating probes. And it's an exponential process. If each probe produces 2 copies, and you keep going, very quickly, in less than 1 billion years, one can fill up the Milky Way galaxy with intelligence. And so we just don't know whether the Earth was visited in the past. But what I'm saying is, let's do our best to look around and check if there are any technological space trash that may indicate that we are in a neighborhood where there are other intelligences. That's all I'm saying. And to me, it sounds like common sense.
Yeah, and do you think that if there are extraterrestrial life, that it's possible that these extraterrestrial life forms visited us in the past?
Yeah,
And I think you had spoken about the potential of them seeding us with intelligence.
yeah, I definitely think so. The problem is that 70 years ago, shortly after Nikola Fermi asked, "Where is everybody?" The scientific community engaged in searching for radio signals. And this is just like waiting for a phone call, because those radio signals move at the speed of light. And if you don't catch them when they pass by you, they will be far away by the time you check. And you might sit at home and wait for someone to call you, but maybe nobody really knows that you're lonely. Okay, and maybe others are attached to the digital screens the way we are, and they don't care about sending us a signal. And on the other hand, space trash is completely different. You can imagine objects being launched from other planets, and they're floating in space at a speed much less than the speed of light. They're bound by gravity to the Milky Way galaxy, the way our space probes are. And then we could just look around and see evidence for them. It's sort of like checking if our neighbor launched a tennis ball that we can distinguish from the rocks in our backyard, and that would teach us that the neighbor plays tennis. So we haven't engaged in that search. That's exactly what I'm trying to do. And that's why I'm going, we are planning to go again to the Pacific Ocean to look for bigger pieces of the meteor that was spotted by US government satellites in 2014, a decade ago. Because
Speaking of
Yeah.
Speaking of the government satellites picking this up, do you think that governments have ever hid evidence of
Well,
extraterrestrial?
this is a very interesting question because there are people claiming from within government that there are programs to study materials that the government found in crash sites or landing sites of unidentified objects. And there were three reports that the Director of National Intelligence, Avril Haines, delivered to the US Congress since 2021. And that led me to establish the Galileo Project, because in these reports, she was talking about unidentified anomalous phenomena. And what we did is establish an observatory at Harvard University that is monitoring the sky 24/7, the entire sky, and it's doing it in visible light and also in the infrared and in radio and audio. And we are trying to see if there are any objects different than familiar objects like birds, drones, airplanes, balloons, satellites. And we are using machine learning software to figure it out. So we are doing a systematic study, because the government talks about anecdotal reports where military personnel see something unusual because they happen to be at the right place at the right time. That's not the way to do science. Of course, the government has a day job, which is national security. My day job is to figure out what lies outside the solar system. I'm an astronomer. So I don't wait for the government to tell us, but they may have found something, and just yesterday, there was uh, some text publicized by Chris Mellon indicating that the US government was discussing some materials that were recovered. I haven't seen the direct evidence for any of this world technologies that the government may have access to, but it's possible that they did. And however, I'm not waiting for them to tell me what lies in the sky, because the sky is not classified. Our oceans are not
Yeah.
classified. And
And
this meteor that I mentioned before was interstellar. It came from outside the solar system based on government data.
so let's talk about that meteor for a second, or let's actually talk about Oumuamua, which you had purported could be an alien probe. So let's say it is an alien probe. What do you think that its creators, the creators of that alien meteor, would be trying to achieve by sending it into our solar
Oh,
system?
both the Oumuamua and this meteor, I'm not thinking about them as functional devices. I think of them as space trash. So, for example, Oumuamua appeared, at least to me, as a membrane, a very thin film, and that could be just a surface layer, like a plastic bag, tumbling in the wind. There is lots of plastic in the oceans, and it's not functional. And so, in the same way, you could have a lot of trash, space trash, where technological civilizations over the past few billion years in the Milky Way galaxy just released into space all kinds of crap that by now is not working, and we might find it, just like the Tesla Roadster car. It's not really a car, it's just space trash. And Voyager, soon enough, once it exits the solar system, will be space trash. It will take it 10,000 years to do this, and it will not be functional at that point. So what I'm looking for is space trash. I think that's the most common thing we will find. And that meteor that crashed into the Pacific Ocean, that also could have been a Voyager-like meteor. Imagine our own spacecraft Voyager colliding with another planet in the distant future, and appearing as a meteor of unusual material strength and unusual speed. And that's what we should be looking for. And then if we find materials of these objects, we can examine whether they appear to be the materials of a rock, a natural object, or something else.
And I know that you've received, as you've mentioned before, some pushback on this. How do you deal with criticism and skepticism from
Well,
some
that's
of
an
your peers?
excellent question. Last week I went to the TED conference, which was an amazing event. I mean, that's my first time. They invited me. I didn't know what to expect. When I came to the green room, I was going over the slides that they had for me for my talk, and suddenly I hear a voice behind me saying, "I can't believe that I'm with Avi Loeb in the same room." And I looked around and I see Barry Weiss, who I admire. She's an advocate for free speech. She's very eloquent, and I never met her. And I also several people there that are quite prominent came to me and said that they've been following me for a long time, and they are really inspired by my work. In fact, the first evening I had dinner with several billionaires who told me that they're really excited by this line of research. So turns out, and that was completely unexpected as far as I'm concerned, but turns out that I have a large fan base of people that follow me and are really supporting. And that explains why I have funding for the research that I've been doing until now. And I'm not a wealthy person. I cannot really at will support all these expensive expeditions and observatories. But for example, just last month, we got funding from the Mellon Foundation to build a new observatory, just like the one at Harvard in Pennsylvania. And I got the Princeton Foundation to fund a postdoctoral fellow that works with me. And I got a few billionaires that are also funding the Galileo Project. So there is a huge contingency of people inspired, and I get emails every hour of the order of a dozen emails from such people. But separate from that, of course, there are some in the scientific community, and I should say these are not necessarily scientists that I respect. These are scientists from the fringes, or actually bloggers, people who call themselves astrophysicists that haven't published a single scientific paper over the past decade. Just check their resume. Those bloggers who call themselves astrophysicists, I will not mention names, check their resume and see if they published a single scientific paper over the past decade. If not, they're pretending to actually be players, but they're not players. It's just like spectators, looking at a soccer match and telling the players how to pass the ball. It's just unacceptable for them to criticize me when they are not really practicing science. I'm practicing science. Every month I have a few papers published. I just had this paper published, submitted for publication about the low Rybicki halos. I had several other papers this month. And the point is, I'm playing I'm doing science, and it's inappropriate for those to pretend that they represent science and that what I'm doing is not necessarily following the method of science. I'm just seeking evidence, and it's a lot of work. Actually, it took us a year to plan the expedition to the Pacific Ocean. It took us 2 weeks to be in the Pacific Ocean and collect the materials from the ocean, the bottom of the ocean, which was a mile deep, and then bring it to Harvard. And it took us 9 months to analyze the materials. Yet there were people who argued, that we should not have gone there because we would not find anything, that what we found is coal ash. And we studied 55 elements from the periodic table and demonstrated it's not coal ash, or that this meteor never existed in the location that we went to because it was actually a truck. And I say to these, look, we are basing the search area on what the Department of Defense gave us from US government satellites that detected the fireball, the explosion that was, quite powerful, a few percent of the Hiroshima atomic bomb energy. And we did not rely on seismometers that these people were criticizing. We just went to that error box given to us by the US Space Command. And that's the agency that is supposed to alert the US president for the launch of ballistic missiles from North Korea. So if you say you don't believe those people, that we should not even trust their data, you're making a very bold statement about an agency that gets $30 billion a year in funding, more than NASA. And, astronomers made that statement over the past year in published papers. They said, we don't believe the data from the US Space Command. Let's just use much more crappy data from seismometer in the area, and those could have been a truck. And then the New York Times publishes that statement as if we went to the wrong place and it was just a truck. And I ask you, if science reporting is really not paying attention to the fact that we relied on US government data, then how can you trust journalists when they report about politics? It's really bad. And all of this is because of jealousy by some scientists that we get the attention of the public, that I'm getting the attention of funders, which is really the wrong reason for them to say what they're saying.
Yeah. You mentioned the Loeb-Rybicki halos, and that was based on data from the James Webb Space Telescope, right? And that generated a lot of buzz. So can you share some insights into your findings with the Loeb-Rybicki halos and what they suggest about the capabilities of the telescope and the early
Well,
galaxies?
so an interesting result, when I wrote a book about the first galaxies in the universe more than a decade ago, 12 years ago, I said that, we summarized in the book what we expect. And then let's see what the Webb telescope tells us. And I told the reporters that, when the book came out, that, of course, it would be satisfying to see all the predictions, um, you know, uh, validated by the data from the Webb telescope, but it would be even more thrilling if we are surprised, because then you learn something new. I mean, what's the point of doing science if you can predict everything? Of course, you will get honors and awards if you were right and so forth. But I'm actually more excited about being wrong, because that could teach us something completely new that we didn't expect. And indeed, the Webb telescope found brighter galaxies than expected. So we expected the first galaxies to appear fainter than they were actually seen by the Webb telescope. And one possible reason is actually that the stars in those galaxies were more massive than the present day stars. It was sort of expected, and I talked about it in my textbook, because when you make stars from the primordial cosmic gas of hydrogen and helium that doesn't have any heavy elements, that gas cannot cool very effectively, and so it makes big clumps of that end up making very massive stars. And massive stars are excellent factories of radiation, much more so than low mass stars. So it's possible that the first galaxies were much brighter than we expected, because they were mainly composed of massive stars. That's one possible explanation. But irrespective of that, the fact that they were bright makes it easier to detect the Loeb-Rybicki halos around them. And so that's the good news. And that's what we discussed in our paper. And, altogether, I think science is really exciting, because on occasion you discover something that you didn't expect, and you learn something new. And, if you think about honors and awards, who cares in the long term? I mean, for me, from childhood, all I wanted to do is realize something that nobody else realized before me. That's the thrill of doing science. I'm driven by the same ambition as a curious kid. I just want to figure out the world, and I want to figure out something that nobody else figured before. And that's basically what drives me. It's nothing to do with people recognizing it, getting likes on social media, or anything else. It's mostly just enjoying the discovery and enjoying nature. Whatever nature brings to our doorstep, we should really embrace. And we should not pretend that we know the answer in advance. We should not pretend that we are the smartest beings in the universe.
So speaking about discoveries and the thrill and ambition to discover, what moment or discovery most challenged your understanding of the universe?
Yeah, so I think the most challenging aspect is that the universe started in a Big Bang, because all the evidence we have, if we go back in time, indicates that there was a moment in time when the density of matter and radiation was infinite, because the universe is expanding. If you go back in time, it was denser and hotter. And at that point in time, which is called the Big Bang, Einstein's theory of gravity breaks down. This is called the singularity, because the curvature of space-time becomes infinite. A good approximation, a good proxy for the curvature of space-time is the density of matter or radiation. So the bigger the density, the bigger is the curvature of space-time. And so if you reach an infinite density, it means that the curvature is infinite, according to Einstein's equations. And we just don't know what happened before that. That's really a crisis. That's why Einstein didn't like the idea of the Big Bang, he was fighting for a steady state universe. He was thinking initially that the universe existed forever because philosophically it's the most appealing option. Why should there be a beginning in time? So he introduced repulsive gravity. He introduced the cosmological constant, the vacuum energy density, what's now called the dark energy, because it produces repulsive gravity, and he thought of balancing the attractive nature of gravity by this repulsive gravity, by adding to the matter in the universe also a cosmological constant. But we know by now that the universe really expands, that it's not in a steady state, and so that that was a mistake on behalf of Einstein. We do have a cosmological constant, but it's part of the expanding universe. And so anyway, that brings us to the question: what happened before the Big Bang? And that will be the question I would like to get an answer to if we encounter extraterrestrials, because they might know the answer, and it
Do you
may.
hope?
Yeah.
Do you hope that there are extra? Do you hope that there are extraterrestrials out there?
Yeah, because it's just like meeting a smarter kid in your class. Okay, so you might say, "Oh, it's a blow to my ego if there is a student that is smarter than I am." But I say, no, it's an opportunity,
What
because
if they're dangerous?
you can learn something new from that student. And if they figured out what happened before the Big Bang, because they understand how to unify quantum mechanics and gravity, it will just save us time. And it would be fascinating to figure it out. Surely there was something before the Big Bang. The question is what. And if we realize what, we might be able to create a baby universe just like the one we have in the laboratory.
Are there any risks to finding extraterrestrial life? What if they're hostile?
Oh, sure. So then you get to the question of natural selection. Okay, so the natural selection of Earth on Earth was driven by survival of the fittest, according to Charles Darwin. Okay, now the question is, what's the meaning of the fittest in interstellar space? And for me, it's the species that is most intelligent, because if you engaged in conflicts too often, you get bruised. That's what happened to empires on Earth. When they got into wars, eventually they lost, and were after a while they didn't exist anymore. And so the trick is to be intelligent enough not to be engaged in acts of aggression over billions of years. And to me, that's a sign of intelligence. Intelligence is promoting cooperation, constructive work, because why inflict damages on other people? I mean, we are used to zero-sum games, because we started in the jungle where there was limited supply of bananas. And if one tribe gets the bananas, the other tribe does not. And so it's a zero-sum game. And the same is true about territories. The same. That's what fuels what happens in Ukraine right now. There is a limited territory, and Russia and Ukraine are fighting for it. Same is true for the Middle East, right? In Israel. And so these are zero-sum games, and we are used to them. But actually, if you think about science, science is an infinite-sum game where everyone benefits from new knowledge, okay? And so if there is an advanced scientific civilization out there, they would realize that there is an infinite-sum game. There is a lot of real estate beyond the planet they were born on. So why fight over territory on a piece of rock when there are so many other stars out there? They will explore the real estate in interstellar space. And that's what I see as the fittest for survival, because they are not limited to their home planet, and they are not really aggressive or confrontational. So if I adapt this optimistic view, then I'm not worried about meeting them, because we are not posing a risk for them. And I don't see them as being very troubled by our existence, because we are relatively primitive if they had more than 1 century of science and technology the way we did. So I look at it as an opportunity for us to learn from them, not as a threat. But not everyone agrees with me. And Stephen Hawking a decade ago said, we should be careful about transmitting radio signals. You might say, okay, we already transmitted. Well, we transmitted for 100 years. Okay, actually a little more than that, since Marconi transmitted the first radio signal. And that those signals reached maybe thousands of stars by now, over the past, at a distance of 100 light years. But there might not be anyone in those thousands of stars, and therefore we are saved. Or if there is someone in those thousands of stars, it will take them a while to reach us back and do something to us. So maybe we are just naive. But my view is that we should benefit from knowing what happened to other civilizations. It will just give us, I call it shock therapy, because we are focused on what happens on Earth. We need shock therapy to change our priorities and look out to the universe and learn from it.
And what are you most excited about for the next 12 months, let's say?
Oh, globally speaking, I'm very excited about AI, because I think it will, no matter what happens, again, there are risks with that technology, but I do think that it will revolutionize society, make it, and take away jobs that are really boring. Why should you have administrators? Why should you have people who manipulate numbers and drink tea all day long and get paid? It will save us on jobs that are boring. And the same is true with robots. They could be used in construction sites. So and this advance in AI is really fast, and it will take us a while to digest how the great potential that it brings. But I'm excited about it. I'm always excited about new things. I like new music. Billie Eilish, I really like her. I don't care much about the Beatles. And the same is true about, especially with technology and science. And I do think that humanities, like philosophers, need to address the ethical challenges with new technologies, rather than keep talking about ancient Greek philosophers that existed at a time when there were no computers, which is pretty much what they're doing. It's really bad practice on their side. If they want to get many more students and people working in philosophy, they should address AI. And I don't see a lot of courses offered by philosophers. But anyway, just to answer on a personal level, what I'm excited by is the next expedition. We are planning to look for bigger pieces of this meteor in the Pacific Ocean. We have already a plan. It will cost $7 million. And I'm seeking funding. And of course, there would be an opportunity for any funder to join us on the ship.
What are the biggest ethical implications with AI?
Oh, okay. So first of all, there are issues to do with privacy. AI systems will have access to a lot of information about individuals. Just to give you an example, a month ago, I was contacted by a graduate student at another university who told me that he's starting a company that will use AI to train it on records of people, including myself. I wrote hundreds of essays just over the past couple of years. I have 3,000 interviews on the internet over the past couple of years. And you can imagine, so he was saying, we could, for example, take our AI system and train it on your stuff, and then it will just behave like you. So it can imitate my voice. It can produce content that resembles me, Avi Loeb, in the best possible way. And then there is the issue of privacy. Like, this system could pretend to be me. And what do I do about it? Okay, that's a difficult question. And it's not just me, of course. It could happen to many people. And then, of course, there is the issue of content. If it's using my content, and plagiarizing it in future content, what do I do legally about it? This is a relatively minor threat. There are many other issues, and they have to do with any harm that AI systems will cause to society. For example, suppose you use AI in an airplane to navigate instead of a human pilot, and then it crashes the airplane. who do you blame? Now, my approach to that is, if this AI system was trained to be a pilot by some company, the company has to take responsibility. But if the AI system somehow developed well beyond the original training given by the company, and it just developed by itself, it's sort of like a kid that leaves the parents' home. When the kid is within the jurisdiction of the parents, then the parents are held responsible for any damages caused by the kid. If the kid goes to a public place and causes damages, you blame the parents, because the kid is not responsible for their actions. But if the kid is living home and becoming independent, autonomous, then you basically blame the kid, this adult. Actually, you call it an adult. And so the same could happen with AI systems, and there needs to be a legal system that punishes, basically takes AI systems out of commission if they generate crimes or damage to society, kill people, or do something bad. And so that has to be worked out. Both the legal system has to address it, but also in terms of ethics. And you can treat it just like you treat humans, because it's an intelligent system, just like humans are. There are many other challenges. I see the training as similar to the education system. You train, the way you educate your kids, you train it on principles that you wish it to follow later on. And so, there are lots of aspects to how to incorporate AI into society. There will be relationships between humans and AI that will become emotional to humans, and it will have implications in politics. It will have implications in any other human interactions. This is a new environment that we never experienced in the past, and there must be ethicists, philosophers, psychologists thinking about the implications and how to embed AI into the human society.
Awesome. Professor Avi Loeb, thank you so much for the time. Let's wrap up here, and then I'm gonna end the recording, and maybe you and I can spend a couple moments debriefing after. For those who have not purchased his book Interstellar, they should check it out. Where can they find it? On Amazon?
Anywhere.
Anywhere.
Yeah.
Well, and thanks again. Here, let me pause the